Hello everyone. Today we're going to be running through two different software packages that can create and then analyze point clouds. So first of all, we're going to be running through Visual SFM, which can be used to actually create the point cloud from numerous images derived from photography. Then we're running through Cloud Compare, which can allow us to trim, subsample, and mesh the point cloud together to create 3D objects. So what we're going to do is open up Visual SFM, which can be found in the Windows Explorer just by typing Visual SFM in. So first of all, what you're going to do with Visual SFM is go File and Open plus multiple images, as you can see here. And so mine's located in our drive, so while I find mine, just bear with me. So you're just going to select all the ones you want. For my case, I'm just going to select all of them and I'm just going to hit open. And now you're going to go to tools and you're going to show the log window, which is this little window here, which just shows how algorithms and such as compute missing pairwise is running, and when the task you've provided for the program is finished. So now we're going to compute the missing pairwise, and as you can see there, mine is already done, but yours will take around 30 seconds. So then we're going to create a sparse reconstruction after that's finished, and what you can see here is it's using the images to create a point cloud. So it just takes key features and uses the image data to create the point cloud there. This is pretty handy as you can interact with the point cloud while it's actually loading it. And you can see that mine was done in 26 seconds, which is pretty quick. I've only got 25 images I'm loading, whereas you guys could have more, which might take a bit longer. We're now going to run a dense reconstruction of this point cloud, so essentially you're going to multiply the points. And so you're going to just choose a location to save it. To save mine is Maroochydore Beach for now, and press save, and then this will run. This will take around 5 to 15 minutes, depends on how big your point cloud is and how many images you have. So what I'll do is I'll go ahead and I'll skip forward for you guys so you can see the final result. So as you can see there, it's just finishing up now, and it took about 320 seconds, which is about 5 minutes. And as you can see here, nothing's changed, and this is because we have to actually go ahead and manually change the view. So go up to the view icon in your toolbar and click down to dense 3D points instead of N-view 3D points. And there you'll have a sparse and dense reconstruction of your point cloud. you can see that there's a lot more points taken from the image data now, but there are still some gaps, which this can be rectified with more images taken possibly from different directions and different angles. As we only did one flyover of the beach at 60 meters altitude, so this was a pretty good result given the amount of effort we went to, which was not much. So now we're just going to open up Cloud Compare there, and you're going to open up your point cloud. So what you can see there is the default directory is .bin, so you're going to have to go change that to .ply or plymesh, just as it won't show up otherwise. So I'll just go ahead and find it. And there it is there. Just going to double click it or tap on it, click open, and what you're going to do here is just check your XYZs and your RGBs are all lining up correctly. If they are, hit apply all, and you'll load your point cloud into Cloud Compare right there. So this allows us to completely analyze the point cloud. You can also, if you have a point cloud of the same area over a different time scale, you can check to see how it's changed. So now what we're going to do is we're just going to click on the point cloud in the database tree to make sure it's selected, and we're going to go ahead and we're going to click the scissors icon right there and segment a piece of point cloud out, just in case anyone's got anything they don't want. So for the sake of this, I'm just going to select this little piece here, as it's not very important. So you just want to left click your perimeter around the points, and then right click once you've set it. Then go and hit the segment out button, which is that one there, and confirm the segmentation. And what it does is it will duplicate that point cloud just without that segmented piece. So I'll zoom in here and you can see there. So I'll just delete that little piece there, and we'll stick with the one I segmented. So now what we're going to do is we're going to subsample the point cloud. This, we wouldn't do that typically for this size of point cloud, but if you've got an extremely dense one, typically which can be seen with FARO scanners, there are normally a lot of points which can be very slow, specifically on those uni computers. So I'm just going to make it about 300 there, and yeah, you can see it's made a lot of spacing between each point cloud, but we'll just delete that because we don't need to do that for ours. That's just for if you're using a laser scanner, really. So now we're going to probably go ahead and make a mesh. So to do that, just go to edit and down to mesh and click Delaunay 2.5D and select the best fitting plane. So make sure that's set to 0 and hit yes to update the normals. And there's your very rough point cloud output. It's unfortunate that point cloud doesn't get to use image data to fill in those gaps, like more expensive software data is, because Cloud Compare is free, so you can't expect it to be perfect. So you've got a few buildings popping up, but yeah, it's all very rough, and you can see the triangulation that's been used via this method. There is another method to mesh in Cloud Compare. It's a lot more detailed. However, if you don't have enough points, then it can sometimes bring out bad outputs, which might be the case here. We're going to go ahead and try it out now. So you're going to hit Poison Surface Reconstruction, and I'll set the octree depth to 10 for this one. But the higher the octree depth, which can go up to 24, will give you a more refined output. You also want to hit density output as SF, and then we'll set the samples per node to 1, leave full depth to 5, and drop point weight down to 2. So we'll hit OK, and we'll just see how long this takes to process. So yeah, as I was saying, the larger the octree depth, the more refined your output will be. But typically you want to aim for around 11 or 12 or 10 on the uni computers, especially because 24 crashes them. I've tried. So now you got these reddish green colors going on. This just means that that's your poison reconstruction there, and it's also displaying the normals in the image, which was taken from the point cloud. So the more red, the better the normals. But we'll move it to RGB coloration for now, and as you can see there, it's a smoother output, but compared to the Delaunay version, but it's missing quite a lot, and didn't fill any of the gaps at all. So we'll probably just roll with the Delaunay version for now. But yeah, have a look between yours and you can decide what's the better version for yourself, and then just roll with that. So now I'll just show you how to save real quick. So just make sure you change your save type to .ply and go ASCII. And it should save. Sweet, thank you very much for listening. Hopefully it was a big help. If you have any questions, just ask Javier, Nick, or myself.